measure motion. Typically, when we're measuring motion, the frame of reference that we use most commonly is Earth, because Earth's a stationary constant. We don't really have to worry about it moving. However, if we want to talk about things that aren't on Earth or include Earth itself, we need to be able to shift our reference frame. We also want to be able to shift our reference frame in specific scenarios, because if we look at certain events, such as momentum and rotation, from different frames of reference, the math gets way easier. So we want to be able to do that. So typically, we consider Earth as a stationary frame of reference. Earth as a reference frame, or a stationary reference frame. And this leads us to today's daily question. I asked you to sit as still as you could and then answer the question, are you moving? Well, let's take a look at what you guys said. So, pulling up the daily question here. Oh, that's not the one I want. This is. So you guys said, yes, you're always moving, at least in small amounts. Earth also rotates while moving through the solar system. Solar system moves through the galaxy. Yes, Earth is moving, therefore you are moving. Yes, very, very slowly. The Earth is moving around the sun and revolving. If you're joining these two, that's actually really quick. This is ridiculously fast. Yes, my position in space is always shifting. Yes, atoms and cells are always moving. You can never sit perfectly still. Yes, Earth is rotating on its axis, and we're also orbiting the sun. Yes, because Earth is moving around the sun. My internal biological mechanisms are, but as I perceive, well, through metaphysics, no. However, that depend entirely on the scale of what you're using to reference my motion. For example, I can say I'm not moving, however, in relation to Earth, I technically am. Yes, because I'm on Earth, and Earth turns around itself. It turns around the sun, too. The sun is moving around the galaxy is moving around the universe, and other galaxies, etc. Yes, Earth is always moving. Yes, cells inside your body are constantly moving, regardless of whether or not you are in a stationary position. Yes, because of the atoms of my body, and Earth is moving. Yes, cells inside my body, and yes, relative to the core of Earth, for example, I am moving very quickly as the surface of Earth moves. My hand is also shaking. Organs move even as I am able to, as I stand as still as I am able. So, you guys kind of lumped your answers into one of two categories. Your first category was biology. You have cells, you have atoms, things are going on. And the second category was astronomy, which really brings us back to this frame of reference idea in terms of historical perspective. Frames of reference really weren't an idea until like the 1600s. When we talk about Earth moving, we really accepted that it was a geocentric system for, well, almost 2,000 years. And some of the leading arguments for why Earth couldn't be moving were because we didn't feel that Earth was moving. You walk, you ride on a boat, you rode in a wagon, and you could always tell you were moving. You felt motion. So if we were riding on Earth and Earth was moving, we should be able to feel that motion. That was the argument. However, when we start to think about more steady motion, we can start to dispute those. How many of you have ridden on an airplane? Okay, most of us. There are 3 times during an airplane ride where you can feel that you're moving. What are those 3 times? Takeoff, landing, turbulence. If we're not talking about takeoff, landing, or turbulence, you don't feel like you're moving. You feel stationary on the plane because the plane and you have the same frame of reference. So just like riding on the plane, we can't feel that Earth is moving because we are in Earth's frame of reference. So from your frame of reference, you are always stationary, and any motion you experience is attributed to outside frames. You are always stationary, and your motion is attributed to outside frames. Some of this can be a little bit difficult to wrap our head around because we're so used to having an absolute frame of reference. Being creatures that live on Earth, we're very used to Earth being an absolute frame of reference. So we can measure everything based on whether or not it's moving compared to the surface of Earth. That works nicely for things on Earth, but if we start to talk about those astronomical possibilities or those astronomical bodies, we don't have that anymore because Earth is definitely moving around the sun if you look at it from any frame of reference other than Earth. So as long as we're not looking at it from Earth's frame of reference, Earth's definitely moving. Okay? And this is a concept that I want to say we were able to put to rest in the 1600s when we figured out that, yeah, Earth goes around the sun because, well, there's all these reasons and measurements that we can use. However, we still have, evidently, people who are trying to figure out that Earth is a sphere. So, I can't say that that's been put to bed. The next piece with frames of reference. We said that we want to attribute your motion to outside frames. We do this by subtracting our motion from all frames. This is done by subtracting our motion from all frames. So one of the best examples of this concept, I'm pretty sure Einstein posed it originally, but it starts with a train, and the train is rolling down some tracks, let's say at 50 meters per second, and we've got a person over here standing on Earth, watching the train roll by. From this person's perspective, how fast is the train moving? 50 meters per second, right? Let's say this is east and this is west. All right, now let's consider a person on the train. From the person A's perspective, how fast is person B moving? 50 meters per second. How fast is person A moving from person B's perspective? How fast is person A moving from person B's perspective? 50 meters per second west. Two ways we can find that. One, when we look here and we say that if we're person B, we want to subtract our motion from all frames. So I would subtract 50, and here I'd get negative 50. That negative 50, well, if this is positive, this must be negative. Now it's 50 meters per second to the west. Okay? How about if I have person B walking? Let's say at 5 meters per second that way. How fast does person A see person B moving? All we have to do is subtract 5 from 50, and we get 45 meters per second to the east, right? Okay. How fast is person B moving compared to the train? How fast is person B moving compared to the train? Should be 5 meters per second to the west. Because both the train and person B have that motion of 50 meters per second, we would negate it between them because they both experience it. Okay? Also, I could look at it and say, well, if I take the 50 that this person's moving forward and subtract it, the train would now be moving at 0. So from person B's perspective, the train would only be moving at this 5 meters per second east. So it looks like the train's going by this way as person B is observing. Questions on this so far? Sure. From person B's perspective, the train appears to be moving 5 meters per second that way. It appears to be moving 5 meters per second because we attribute this guy's motion to the train. So I subtract my negative 5 meters per second from his motion. I subtract that negative 5 from this frame as well, and I get that this frame, negative, I get now is moving 5 in the positive direction. Alternatively, if you walk towards the back of the plane, it appears as though the plane is coming forward to meet you as you roll towards the back of it. Same thing with the train. As you move towards the back of the train is coming forward to meet you. Good? So again, the math in this is really easy. However, the concepts, I can tell they're making some gears turn. Okay? I'm going to do one more thing here. Now let's say the person has decided to start walking 10 meters per second forward. How fast does the train appear to be moving from person A's perspective? Yeah, 40 meters per second east, because now it doesn't appear to be going quite as fast. We observe this anytime you're on a highway and somebody passes you. It doesn't look like the person passing you is going 80 miles an hour if you're driving 75. How fast does it look like they're driving? 5. And that's how far ahead they're going to get you is 5 miles per hour that you guys drive. All right? So I'm going to give just a quick table here that I want you to fill out. Let's say A, B, C, D. And I want person on the train, person on train, and person on Earth. What I'd like you to do is take a moment and discuss with your neighbor, figure out from reference frame A, how fast is the person on the train moving? From reference frame B, how fast is the person on the train moving? From reference frame C, which is the train, how fast is the person on the train moving? And from reference frame D, which is Earth, how fast is the person on the train moving? And then all the same questions for the person on Earth. The person in reference frame A is moving 10 meters per second to the east. Yes. Take a moment, see if you can fill this out. First, which are the easy two? What about them? So if I'm going to look at reference frame B, and I want to know how fast the person on the train is moving from the reference frame of the person on the train. How fast is he moving? 0. Because you are always stationary in your reference frame. So person B is moving 0 compared to person B. All right? Person A, which is the person on Earth. How fast is person A moving compared to reference frame A? Also 0, because person A is in reference frame A. And that's when we're not moving. All right? Next up, next easy ones. D. D is the reference frame of Earth, right? How fast is person A moving compared to the reference frame of Earth? 10 meters per second east. All right. Next up, frame of reference of the train. How fast does the train observe the person on the train to be moving? 5 meters per second west. Okay. Those are, in my opinion, the easy ones. How are we doing so far? Yes. Yep. Because we think right now we're standing still. That's because we picked Earth as our reference frame. If you're on Mars, no, we aren't. We are not standing still. All right, let's go on to D here. From the reference frame of Earth, how fast does it appear this person is moving? We've got to account for the train and the -5 here. So 45 meters per second east. From the reference frame of the train, how fast does it appear the person on Earth is moving? How'd you get 40? Right. So if we are the train, we need to subtract our 50 from the other frame, meaning we get 40 meters per second to the west. All right. Last ones are the tricky ones. From reference frame A, meaning this person, B appears to be moving how fast? Say again? 35 meters per second east. We can figure that one out simply building off the Earth. So from Earth's reference frame, they were moving 45 forward. However, now we're shifting to person A's reference frame, so we're going to subtract that 10. Subtracting 10 from 45, we get 35 east. We can also know that this one's got to be the exact opposite because it's the same objects, just jumping from this guy's view as to how fast that person is moving. How many of you got at least half of these? Good. Anybody get a perfect? All right. It's our first try, so I'm not entirely surprised. All right.